Today we're looking at the volume of prisms and cylinders. Our goal is to find the volume of prisms and cylinders. In my opinion, this is much easier than surface area. I hope you all agree. Vocabulary. The volume, that is the amount of space a solid occupies. I think of it as the amount of stuff you can fit inside a solid. How much stuff will the solid hold? So for example, how can we figure out the measure of the amount of stuff that would fit in this prism? Well, we got to think about the bottom part, okay? We've got our length and we've got our width. And we filled up that area. We'll go ahead, and that's our bottom layer. So we start with length times width. But then what happens, we want to fill up the entire solid, we're going to color up. So we multiply by the height of the solid as well. So we have length times width times height. Now, that is the formula for a rectangular prism. This also works for any prism we have. The length times the width gives us the base of the solid. So we use a capital B for the base times the height. Must use a capital B. That is our formula for any solid's volume. So we're going to find the volume of the following prisms. We'll start with a rectangular prism. I want us getting used to this common formula of base area of the base times the height. So B times H. Now we can turn this box however we want to turn it, but in this case it looks like we've got a 12 by 8 for our bottom layer. That's our base. So we'll say 12 times 8. And the height of the prism is 2 inches. So we do it times 2. Multiply it all together. 12 times 8 gives us 96. 96 times 2 gives us 192 inches cubed. We're doing cubed because we're in 3 dimensions, length, width, and height. So inches cubed. Now over here, we have a triangular prism. We have a couple of ways we can go about doing this. We're going to stick with our volume formula. Okay, area of the base times the height. Remember, the base is the non-rectangular side. So even though the triangles are in the front and the back in this drawing, those are the bases. So the area of the base, well, for a triangle, it's the base of the triangle times the height. Remember, we cut it in half. So this 4 times 3 times a half. That gives us the area, okay, of the base part. We take all of that and multiply it by the height, which is 10. And I'm low on room here. That's a 10, I promise you. So there's our formula. Now we go ahead. We know we can multiply any order we want. So I'm just going to go, let's see. 10 times 3 is 30. Half of that is 15. 15 times 4 is 60. 60 meters cubed. So again, area of the base times the height. That base area changes based off of our solid. We go over to cylinders. Same exact formula. Again, just a different way of finding our base area. So we do area of the base times the height. And we have a circle base, so to find that circular base area, we do pi r squared. So we use pi, 3 14/100ths, times the radius squared. We notice diameter here is 6, which means the radius is 3, times the height of the cylinder, which is 9. We simplify this, and I'll keep this pi here. And we've got 9 for 3 squared, 9 over here. And keep working down. Everything we can do mentally, we're here. Now I'll pause the video while I grab a calculator and figure out the final answer. Back with our final answer of 254 34 centimeters cubed. This concludes your lesson on volume of prisms and cylinders.